calculate the electrical load for an apartment, we can use different methods. One such method is the area method. For this, we need the square footage of the apartment. The multiplier typically used is 3 watts per square foot. Regarding the equipment load, it's important to consider appliances. In this case, there are no laundry appliances. The apartment uses gas for cooking, heating, and hot water, which means there's minimal electrical load from these sources. To perform the calculation using the area method, we need the square footage of the apartment, which was not provided. However, there is information stating that the current draw with everything on is approximately 30 amps. Based on this information, the total load is 30 amps. The city inspector has approved a 100 amp panel if the load does not exceed 80%. 80% of 100 amps is 80 amps. Based on the current draw of 30 amps, the apartment would qualify for a 100 amp panel. However, if the actual load exceeds 30 amps, a 200 amp service might be required. Also note that this calculation does not account for future load increases. It's important to consider the maximum number of circuits allowed on a 100 amp panel, which is usually around 20 to 24 circuits. If planning to add additional appliances or circuits, you may need to upgrade to a larger panel. Calculating electrical loads accurately is essential for safety and compliance with electrical codes. In the absence of the apartment's square footage, the provided information indicates a total load of 30 amps. With an existing load of 30 amps, the inspector has approved the installation of a 100 amp panel, provided that the load does not exceed 80% of the panel's capacity, which is 80 amps. This suggests that the 100 amp panel is adequate for the current load. However, several additional factors should be considered to ensure the safety and reliability of the electrical system. Firstly, the existing load of 30 amps represents the current demand on the electrical system. It is important to account for any potential future load increases. This can include the addition of new appliances, electronic devices, or other electrical equipment. It is recommended to overestimate the potential future load to avoid overloading the electrical system. Secondly, the load calculation should be based on the continuous load, which is the maximum load that is expected to operate for 3 hours or more continuously. The National Electrical Code (NEC) requires that the overcurrent protection device, such as a circuit breaker or fuse, be sized to protect the conductors from overload. The NEC specifies that the continuous load shall not exceed 80% of the rating of the overcurrent protection device. Therefore, it is important to ensure that the circuit breaker or fuse is sized appropriately for the continuous load. Thirdly, the load calculation should consider the voltage drop in the electrical system. Voltage drop occurs when the voltage at the end of a circuit is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or fail prematurely. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. It is important to select conductors of sufficient size to minimize voltage drop. Fourthly, the load calculation should account for the ambient temperature. The ampacity of conductors is affected by the ambient temperature. The NEC provides tables that specify the ampacity of conductors at different temperatures. It is important to select conductors with an ampacity that is appropriate for the ambient temperature. Fifthly, the load calculation should consider the type of wiring method used. The NEC specifies different ampacity ratings for different wiring methods. It is important to select a wiring method that is appropriate for the application. Sixthly, the load calculation should account for any special loads, such as motors or welders. Motors and welders can draw high inrush currents, which can cause voltage drop and overload the electrical system. The NEC provides specific requirements for sizing conductors and overcurrent protection devices for motors and welders. Seventh, it is important to consult with a qualified electrician to perform the load calculation and ensure that the electrical system is installed in accordance with all applicable codes and standards. A qualified electrician can assess the existing electrical system, determine the load requirements, and recommend the appropriate panel size, conductor sizes, and overcurrent protection devices. Finally, remember that electrical work can be dangerous and should only be performed by qualified individuals. Always turn off the power before working on any electrical equipment. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. Considering these additional factors will help ensure that the electrical system is safe, reliable, and meets the needs of the apartment. When performing a load calculation for an apartment, especially when dealing with existing infrastructure and potential limitations such as the number of allowable service cables, it's crucial to adhere to the guidelines and requirements set forth by the National Electrical Code, NEC, and local electrical codes. Firstly, let's address the area method, which is a common approach for estimating the general lighting and receptacle load in a dwelling unit. According to the NEC, specifically section 220.12, a minimum of 3 volt-amps per square foot is required for general lighting and general use receptacles. This value accounts for the anticipated usage of lights and small appliances throughout the apartment. Without the square footage of the apartment, we can't accurately apply this method. However, if the square footage were available, you would multiply it by 3 volt-amps to obtain the total volt-ampere requirement for general lighting and receptacles. Secondly, when considering appliances, it's important to differentiate between fixed appliances and portable appliances. Fixed appliances are those that are permanently connected to the electrical system, such as a range, water heater, or air conditioner. Portable appliances, on the other hand, are those that can be easily moved and plugged into a receptacle, such as a microwave, toaster, or coffee maker. In this particular scenario, you mentioned that the apartment uses gas for cooking, heating, and hot water. This significantly reduces the electrical load associated with these functions, as gas appliances typically consume very little electricity. However, it's still important to account for any electrical components of these appliances, such as the igniter for the gas stove or the control panel for the gas furnace. These components typically draw a small amount of current, but they should still be included in the load calculation. Thirdly, since there are no laundry appliances in the apartment, you don't need to include a load for a clothes washer or dryer. However, if there were laundry appliances, the NEC provides specific guidelines for calculating the load. For example, section 220.52 specifies that a minimum of 1500 volt-amps must be included for each laundry circuit. Fourthly, let's discuss the concept of demand factors, which are used to reduce the calculated load based on the assumption that not all electrical equipment will be operating simultaneously at their maximum capacity. The NEC provides demand factors for various types of loads, such as lighting, receptacles, and appliances. These demand factors are based on statistical data and reflect the typical usage patterns of electrical equipment in dwelling units. In your case, since the apartment is relatively small and has a limited number of electrical appliances, you may be able to apply demand factors to reduce the calculated load. However, it's important to exercise caution when applying demand factors, as it's always better to overestimate the load than to underestimate it. Fifthly, it's essential to consider the existing electrical service and the limitations imposed by the city inspector. The fact that you can only run one more service cable and that there are already multiple services off the same service loop raises concerns about the overall capacity of the electrical system. The city inspector's requirement for a public meter for 6 lights indicates that there are concerns about the potential for overloading the system. The inspector's allowance for a third 100-amp panel, provided that the apartment's load does not exceed 80%, is a critical factor in determining the appropriate panel size. Sixthly, to accurately determine the apartment's electrical load, it would be ideal to perform an actual load measurement using an amp meter. You mentioned that an amp meter reading with everything on would draw about 30 amps. This provides valuable real-world data that can be used to validate the load calculation. However, it's important to note that this measurement represents the instantaneous load at the time of the measurement. It doesn't necessarily reflect the maximum demand that the apartment will experience over an extended period. Seventhly, based on the information provided, the apartment's electrical load appears to be relatively light. The fact that the current draw with everything on is only 30 amps suggests that the 100-amp panel should be adequate for the apartment's needs. However, it's important to remember that this is just an estimate, and it's always better to err on the side of caution. Eighth, it's important to consider the number of circuits that will be installed in the apartment. The NEC specifies the maximum number of outlets that can be connected to a single circuit, depending on the type of load. For example, Section 210.21 specifies that a 15 amp circuit can serve a maximum of 12 outlets, while a 20 amp circuit can serve a maximum of 10 outlets. It's important to ensure that the number of circuits is adequate to handle anticipated load and to prevent overloading any individual circuit. Ninth, consider the impact of future load increases. As the apartment is renovated and new tenants move in, there is a possibility that the electrical load will increase. This could be due to the addition of new appliances, electronic devices, or other electrical equipment. It's important to factor in the potential for future load increases when determining the appropriate panel size. Finally, it's strongly recommended to consult with a qualified electrician to perform a comprehensive load calculation and to ensure that the electrical system is installed in accordance with all applicable codes and standards. A qualified electrician can assess the existing electrical service, determine the load requirements, and recommend the appropriate panel size, conductor sizes, and overcurrent protection devices. The electrician can also advise you on the best way to address any limitations imposed by the city inspector and to ensure that the electrical system is safe, reliable, and meets the needs of the apartment. Remember that electrical work can be dangerous and should only be performed by qualified individuals. Always turn off the power before working on any electrical equipment. If you are not comfortable performing electrical work, it's best to hire a qualified electrician. The electrical load calculation for your apartment renovation project involves several key considerations to ensure safety, compliance with electrical codes, and sufficient capacity for current and future needs. Here's a breakdown of the process and factors to consider. Firstly, the area method as per the National Electrical Code, NEC, Section 220.12, requires a minimum of 3 volt-amps per square foot for general lighting and receptacles in dwelling units. To use this method, you need the square footage of the apartment, which you didn't provide. Multiply the square footage by 3 volt-amps to determine the total volt-ampere requirement for general lighting and receptacles. This provides a baseline for the electrical load based on the size of the living space. Secondly, appliances. Since the apartment uses gas for cooking, heating, and hot water, the electrical load from these appliances is minimal. However, account for any electrical components, such as ignitors or control panels, which may draw a small amount of current. If electric appliances were present, each would need to be calculated separately, considering their nameplate ratings and any applicable demand factors. Thirdly, laundry. With no laundry appliances in the apartment, there is no need to include a load for a clothes washer or dryer. If laundry appliances were present, the NEC Section 220.52 specifies a minimum of 1500 volt-amps for each laundry circuit. Fourthly, demand factors. Demand factors allow reducing the calculated load, assuming that not all electrical equipment operates simultaneously at maximum capacity. The NEC provides demand factors for various loads, but exercise caution when applying them, as overestimation is preferable to underestimation. Given the apartment's small size and limited appliances, you might consider demand factors, but ensure the calculation remains conservative. Fifthly, existing electrical service. The existing service and the limitations imposed by the city inspector are crucial. The fact that you can only run one more service cable in the presence of multiple services off the same service loop raise concerns about system capacity. The inspector's requirement for a public meter for 6 lights suggests concerns about overloading the system. The inspector's approval of a third 100 amp panel, provided the apartment's load doesn't exceed 80%, is a key determinant. Sixthly, actual load measurement. The amp meter reading of 30 amps with everything on provides valuable real-world data. This measurement represents the instantaneous load at the time of measurement, but doesn't necessarily reflect the maximum demand over an extended period. Use this data to validate the load calculation, but consider potential fluctuations and future load increases. Seventhly, panel size. Based on the provided information, the apartment's electrical load appears relatively light. The 30 amp current draw suggests the 100 amp panel might be adequate, but it's essential to account for potential future load increases. Ensure compliance with the inspector's requirement that the load doesn't exceed 80% of the panel's capacity, which is 80 amps for a 100 amp panel. Eighthly, number of circuits. Determine the number of circuits needed in the apartment, considering the NEC guidelines and the maximum number of outlets per circuit, typically 12 outlets for a 15 amp circuit and 10 outlets for a 20 amp circuit. Ensure the number of circuits is adequate to handle the anticipated load and prevent overloading individual circuits. Ninthly, future load increases. Account for potential future load increases as the apartment is renovated and new tenants move in. The addition of new appliances, electronic devices, or other electrical equipment can increase the electrical load. Factor in these potential increases to ensure the electrical system remains adequate. 10th, professional consultation. It's strongly recommended to consult a qualified electrician to perform a comprehensive load calculation and ensure the electrical system complies with all applicable codes and standards. A qualified electrician can assess the existing electrical service, determine the load requirements, and recommend the appropriate panel size, conductor sizes, and overcurrent protection devices. The electrician can also advise on addressing any limitations imposed by the city inspector and ensuring the electrical system is safe and reliable. Finally, remember that electrical work can be dangerous and should only be performed by qualified individuals. Always turn off the power before working on any electrical equipment. If unsure, hire a qualified electrician.